happened in research. So I cannot even claim that they copied us. But it's life. But the interesting thing that we go from a map like this, and you click in a bridge in the United States, and you say this bridge collapsed, and then you start showing power plants. I don't have 95 to 100% of my coal. I don't have 60 to 95% of my coal. So you just click in any transportation asset from the railroad and the barges in the US and say this is affected by hurricane, or you can get the hurricane prediction passing through here. You see all the assets that are in that path, and then you come up with those power plants popping up as problems. Oops! Then the student had the brilliant idea to create a railroad map of the United States by criticality. And he had some railroad segments that had, if affected, would affect, he decided by number of Americans that would be affected by the removing that railroad out of connection. So he came up with some segments of railroad that would have more than 60 million Americans without electricity. This segment of railroad is, so he ranked all railroad and bridges in the United States by criticality. The data allowed him to do that. What happened? When he presented that Department of Energy, there are 5 generals running like crazy in the back, money disappeared, and was never able to publish their work. They realized that this is extremely dangerous. A terrorist would have target of bridges to blow the United States. What was it? It's basically telling terrorists what's the best bridge to blow. Okay, so again, be careful when you present your results and your results. So we are not going to see, we're going to see one small presentation, publication in this research with hypothetical data. So, and then they hired a student, and the student worked for the Department of Energy since then. And I heard that the system is, the solution, now it's with gas pipelines too. So they can predict the effect of pipelines. That's much more difficult than railroads, because railroads don't have so many options, but those they have. So I'm not going to have time to talk about this one. I have 5 minutes. But again, this is looking at water data. This one I would like to talk about because this is a very successful research. This was done with a colleague, Scott Mattels, when I was at Carnegie Mellon, and with a student, Marty Berges, that is now a professor at Carnegie Mellon. This is started from a curiosity in my own house, the why guy. Why things are like this? I decided to save energy. And I went like everyone does. I went to Home Depot and bought expensive LED bulbs. At the time, very expensive. Replaced all the bulbs for hundreds of dollars. And then next month, my bill came exactly the same as the previous month. And I said, oh, damn, what's going on here? And then I realized, look, I'm always at the office. I don't use lights at home. It's not the lights that is the problem. If you don't turn the lights on, you don't consume energy. It doesn't mean that you went from a 100 watts bulb to a 5 watts bulb. You are saving 95 watts per hour that the light is on. Okay? So basically, I never knew. I would love to know, to learn from my house, where is my bill coming from? Something like I call like an electricity bill that looks like a supermarket bill. I like a supermarket. I go to the supermarket. I see I spend $100, $30 in red meat. This is obscene. So I have, if I decide to be a vegetarian, oh my God, I'm going to save $75, $80 a month, and I can make those types of life decisions in a budget way, looking at my savings. The same thing with electricity. I have a bill of $100. I have no clue how I spend. I would love to say from the $100, we spend $30 in air conditioning. We spend $15 in our refrigerator. We spend $10 watching TV. So I would be, okay, I'm spending all this on TV, so let's replace my plasma TV for a LED TV, and I would be able to save more money than replacing all the bulbs. So those types of decisions that was difficult to make. So I challenge, and this is pretty interesting. You have, from the whole energy in the United States, 40% of the energy grid in the United States is to produce electricity. And 73% of the electricity in the United States is to residential commercial buildings. So we talk about cars, your transportation people talk about high efficient cars and this and that. There is more impact in the energy grid in the United States if you improve the way that we interact with our houses, making them more efficient. So what happened is that we went and used my house as a prototype. We developed a wireless sensor that you connect to the outlet, and then you connect your refrigerator in that thing. It's a wireless, so every energy that passes through the wall into the refrigerator, that sensor measures, is a meter, and sends to my central computer at home that start looking at the consumption of all the appliances. So I put a sensor in every appliance. It worked. I found out I was able to cut my energy bill in 35%, but the cost of my system was $60,000. Okay, I had each sensor cost me $900 and those things. So I went through all those things and I realized, look, the cost benefit, it's not there. My bill was $100. It went down to $65. For $35 a month, with an investment of $60,000, it's not there. So I challenged Mario, and we were looking. I said, Mario, you have to do this with $5. $60,000 to maximum $30. So the interesting thing is that you're looking to the idea. This is the coffee machine at the department. Here is someone getting, this is the water heater. This is someone getting tea. This is someone getting coffee. So the tea is just a pump. The coffee, there is the grinder and the pump. So we start looking at, with one sensor, we could start looking by spikes of energy consumption, recognize that spike to some appliances. So we call it non-intrusive load monitoring, NIOM. We got several patents on that. So the idea, you have in a house, you have a sensor, and you go, this is a house. The stereo is turning on, the bulb is turning on and off. So you start doing this recognition from one sensor in the main feed in the house, and always done software based. So you are now able to create that bill that looks like the supermarket bill, and you can do it real time. At any instant, you can see how much you are consuming and what is the appliance that is consuming what. So pretty cool thing. What we learned from that? We deployed in 50 houses, just to wrap up. How engineering research is never going to solve the world problems. We have to go beyond that. Okay? Just being engineers, narrow-minded as engineers, would not solve the whole problems. We deployed in 50 houses. We got very high savings for 1 month, and then people said, wherever. Okay, yeah, your beer is warmer because you changed your air conditioning. Your house is hotter because you changed the thermostat. First, you're playing the system to see how much you can save. Then you realize at the end of the month that you save $20, $30 and say, I don't care, $30, I want a cool beer. So people went back to their behavior. So we added professors in psychology and sociology to the team. So we started, so what we are working now, we're starting how you change human behavior. I have this data, and then you guys in transportation do a lot of that. How you change ways people to use public transportation from the other types of transportation. In the other engineers, in our area, construction, IT, we are not used to understand human behavior. And so you're doing a lot of cool things. We are called human building interaction, trying to see how people behave in buildings. A lot of good brands going on in this direction. Thank you very much. I'm going to take some answers.
Okay, thank you very much. A couple of minutes, so just one question.
So I didn't start on my current research.
Any people have a question? Okay, if not, since I think the students are going to come in, they're all waiting outside now. Okay, with that, please join me again. Thank you very much for the